Okay, so yesterday we're looking at dependent and independent probability. Now we're going to look at what we call mutual exclusive or not mutual exclusive. Now, mutual exclusive are things that cannot happen at the same time. Cannot. Now imagine in high school, like probability of playing basketball and probability of playing soccer, it cannot happen at the same time. That's mutual exclusive. Now, not mutual exclusive is that, yeah, they can both happen at the same time. Okay, so probability of playing basketball and probability of winning, right? They can both happen at the same time, so that's not mutually exclusive. So let's take a look. A cooler contains 13 bottles of sports drinks. There's 5 lemon lime flavored. So let me write 5L, well, that's 5 lemon lime flavored. There's 4 orange flavored, so 4O, and then 4 fruit punch flavored. So let me write 4P. And that should be 13 bottles of sports drinks. You randomly grab a bottle. It is a lemon lime or an orange. Okay, so first I have to think, probability of being lemon lime. So let me do probability of L. So probability that I get a lemon lime flavored drink. And then I have to consider probability of orange. Then I ask myself, can they happen at the same time? Can I get a drink that it's lemon lime and orange at the same time? In this case, no. So these are what we call mutually exclusive, right? It cannot happen at the same time. And I'm just going to add my probabilities because I'm using the word or. Okay, probability of this being a lime flavored drink is 5 out of 13 because there's 5 lemon limes, there's 13 bottles altogether. Probability of this being an orange drink is 4 out of 13. Let me just add my two probabilities. Again, when we use the word or, we add. So this is going to give me 9 over 13. We see as a decimal 9 divided by 13 is like 0.692. Now let's take a look at number 28. There's a basket that contains 4 apples, 4 peaches, and 5 pears. So let me write my information. 4 apples, 4 peaches, and 5 pears. There's a total of 13 fruits. Okay. You randomly select a piece of fruit. It is an apple or big key or a peach. Now, can I get a fruit that is both? No. So this is what we call mutually exclusive. Okay, so I'm going to say probability of an apple plus the probability that is a peach. Okay, so I have 4 apples. There's 13 altogether. So I'm going to say 4 over 13. Probability of a peach, there's 4. There's 13 altogether. So 4 over 13. I'm going to add. When we use the word or, we add. So this is going to give me 8 of 13. So 8 over 13. That's a decimal. 8 divided by 13 is like 0.615. As a decimal, it's always a number between 0 and 1. That's good. Okay. Number 29. A bag contains 4 yellow tennis balls, number 1 to 4. Okay, so let me just say it. Yellow 1, yellow 2, yellow 3, yellow 4. The bag also contains 3 green tennis balls, numbers 1 to 3. So I'm going to say green 1, green 2, green 3. You randomly pick a tennis ball. It is yellow or has a number greater than 2. So let me do probability that is yellow plus. Now, so one of its probability is yellow. The other one's probability is a number greater than 2. I ask myself, can this happen at the same time? Yes. Probability of getting a yellow number 3 or yellow number 4. So this is what we call not mutually exclusive because they can happen at the same time. So I'm going to say for this other one, I'm going to say probability that it's a numbered greater than 2, because I had to pick a number greater than 2, but it's not yellow. Okay, so to begin with, probability that it's yellow, it's 4 out of 7. Now, probability that's bigger than 2, but it's not yellow, basically a number greater than 2, but it's green, well, I have 1 out of 7. 4/7 plus 1/7 common denominators. This gives me 5/7. Take a look at number 30. There's a bag that contains 3 white jerseys, number 1, 2, 3. Okay, so let's say white 1, white 2, white 3. The bag also contains 3 red jerseys, number 1, 2, 3. So red 1, red 2, red 3. You randomly pick a jersey. It is red or has an even number. So first I'm going to see what's the probability that I get a red jersey. Plus, because it's or. Now even. Can I pick a red jersey and even? Yes. Okay, so I'm going to say probability that it's even, but not red. Because I don't want the even red jerseys to count twice. So probability that it is red, it is 3 out of 6. Probability that it's even, but not red, basically probability that it's even in white, well, I have 1 out of 6. When I add this, it's 4/6, which simplifies to 2/3. Cool. Take a look at number 31. There's a basket that contains 3 apples. Let me write 3 apples, 5 peaches, and 4 pears. You randomly select a piece of fruit. It is an apple or peach. So probability is an apple or, so I add, then peach. This little p outside of the parentheses means probability. So probability that is an apple. Let me fix this right here. Notice I didn't write probability is a peach given that it's an apple because it cannot happen at the same time, right? This is mutually exclusive. They cannot happen at the same time. So probability that is an apple, I'm gonna say 3 out of 12. There's 3 apples, there's 12 fruits altogether. Now probability that is a peach, it's 5 out of 12. When I add this, I get 8/12, which simplifies to 2/3. Now question number 32. You're going to roll a fair 6-sided die. Okay, so the die, we know that it gives me either a 1, a 2, a 3, a 4, a 5, or a 6. That's what we call a 6-sided die. The die shows an odd number, the probability that it's an odd, or, so that's, I do a plus, a number greater than 2. Can it be a greater than 2 and odd? Yeah, it can happen at the same time, so this is not mutually exclusive. So let me write this thing out as it's greater than 2, but not odd. Because I already counted all the odds. So, okay, probability that it's an odd number, right? Odd numbers are like 1, 3, 5. So there's 3 out of 6. Now, probability that it's greater than 2, so my focus is on these numbers, greater than 2, but not odd. There's 2, right? There's 2 of those. Now, this goes over 6 because there's still 6 numbers all together, right? The die. Now, when I add this, it's going to be 5 out of 6. Now in symbols, let's take a look in symbols. probability of A, when these are mutually exclusive, what we were doing is probability of A plus the probability of B was equal to probability of A or B. Let me replace my values. The probability of A is 7/20. Probability of B, I have no idea. Let me call it X. Equals probability of A or B. Let me call this 9/20. We're dealing with fractions because probabilities are fractions. I'm solving for X. So we know that this 7/20, let me move it over as a minus 7/20. Common denominator, so that's nice. I'm gonna get that X is equal to 2/20, better known as, oh, not 9/20. This was actually 9/10. 9/10 minus 7/20. Now my 9/20, let me call that 18/20. My 9/10, I mean, let me call that 18/20 minus 7/20. I need common denominators. So I'm gonna say this simplifies to 11/20. Okay, that's easy. Now find this probability here. I will say, here it doesn't tell me whether they're dependent or independent. Let me check something really quick. Probability of A times probability of B equals probability of A and B if they are independent. 11/20 times 11/20 equals 143/400. No, this is not independent. Okay, so I'm gonna say probability of A. Let me use the word or instead. I'm gonna say probability of A plus the probability of B. For right now, let me leave a space. And this is gonna be equal to probability of A or B. If this were independent, just do that. Probability of A plus probability of B equals probability of A or B. Now, because these are not independent, on the space that I left here, let me subtract when they are the same thing, right? They can happen at the same time. So I'm gonna have 11/20 plus 11/20 minus 143/2/400. It's equal to X. Ooh, okay, get common denominators. The first two fractions, let me multiply each by 20. So I have 220/400 when I use this space down here, plus 220/400 minus 143/400 is equal to X. I wanted common denominators. There's a 400 at the bottom. Now I'm just going to do the top. 220 plus 220 minus 143, and that gives me 297. Doesn't simplify anymore, so that's good. 297/400. Beautiful.